So, hi everyone, I'm Maxime Bertauts and I'm doing my postdoc at Laval University. And today I will talk about how I decipher the gold precipitation events through the Pyrite Infrared Imaging and the 3D inclusion analysis in the Triangle and Ormaque Orogenic gold deposit in the Val-d'Or, Abitibi, Québec. So first of all, I will just do a quick remind about what we considered as an orogenic gold deposit. So generally, they are associated to second or third order shear zones, and they precipitate around close to the brittle plastic transition, and we often imply an influx of metamorphic fluids that is mainly aqueous carbonic with some salts. So here it's the Triangle and Ormaque are two orogenic gold deposits, and they are located in the Abitibi greenstone belt southeast of the Superior Province. They are located in the Val-d'Or district that hosting numerous gold deposits along the major Cadillac-Leader Lake fault zone. And these orogenic gold deposits are hosted in volcanic rocks and felsic volcanic to late tectonic intrusions. Most of the gold is hosted in quartz tourmaline carbonate veins, which I call it for the rest of the presentation QTC veins. So here you have cross-section of the Triangle and Ormaque deposits. So they are hosted in the Neo-Archean Val-d'Or formation, which is composed of this basaltic pilolava and andesitic tuff, volcanic diuretic intrusions, and post-volcanic gabbroic to diuretic cylindrical intrusions. As you can see, the quartz tourmaline QTC veins in Triangle are hosted by these shear zones, subvertical shear zones, while in Ormaque there appears more a flat extension QTC veins. So how can we form both? So it was described till the early 90s by, notably by Robert in the Sigma mine. He proposed the fold valve model to explain the formation of this shear zone and this extension vein quite at the same time. Here we have some example of what we found in the shear veins of Triangle. So mostly we can find a lot of pyrites. Those pyrites are usually close to suboidal, and they can host some gold. Also, the gold is found in cracks. In the extension vein of Ormaque, we can have like huge pyrite grains. This one is around 10 centimeter size. Some of these pyrite can host inclusion of gold. Also, we can find some gold in the disseminated in massive micrometric tourmaline bands, and also in cracks or in tourmaline stylolite. So we use the Pyrite near-infrared microscopy to concentrate the fluid story in the QTC veins. Some of the opaque mirrors, such as the pyrites, let pass the near-infrared light, meaning that they appear translucent at those wavelengths. The pyrite transmittance is directly related to the pyrite trace element content and the thickness of the sample, and it allows to determine the texture and fluid inclusion in pyrite. So here you have an example of a pyrite under near-infrared, and here under reflected light. The advantages of this method of the near-infrared microscopy and 3D inclusion study in pyrite is that the pyrite is ubiquitous in those orogenic gold veins, is also one of the main hosts for gold, as we've seen before, and is less affected by deformation than quartz, so it can preserve pristine 3D inclusions. I will first begin by to show you the textures that we've seen in the pyrites. So first, we've defined two primary textures. First one is this opaque homogeneous core, always followed by oscillatory growth zoning. This oscillatory growth zoning indicate open space precipitation, and it doesn't seem to be related to fault valve precipitation, or it might be not the case. Then we have primary textures disturbances, which we called it Pyrite 3. So the things that is interesting is that we have this progressive disturbance of the textures from this wavy disturbance to lamella and then further lag textures. So to the disappearance of the primary textures that highlight an increase of the elementary mobility. This progressive transition from the primary textures to this Pyrite 3 might be indicate deformation. Then only in the shear veins of triangle, we've seen diverse secondary textures, mostly dissolution reprecipitation, such as this Pyrite 4, followed by this Pyrite 5, 6, and even this 7, that is this remobilization of the Pyrite textures around cracks that contain gold. One thing that is interesting is that this Pyrite 4 dissolution reprecipitation textures host numerous acicular zinc sphalerite inclusions, and it have been found in the main shear zones of triangle, so the C2 and the C4, and never found in Ormaque, and so in the extension vein of Ormaque. And the first new samples that I've seen from that Robert gave to us, that's from Sigma, we also seen these textures, and we doesn't have for now an explication of why we have this zinc at this moment in those pyrites. The things that we have to keep in mind is that the most common textures are the primary textures, so Pyrite 1 and 2, and the Pyrite 3, which is the disturbances of the primary textures. So to resume, we have mostly the primary textures and the overprint of these primary textures by the Pyrite 3. Then in triangle, we can in the shear zone, in the shear vein, sorry, we can see those dissolution precipitation and fracture control dissolution textures. So this last texture seems to appear after the fault valve model and in a more maybe brittle condition, so later in the system. But where is the gold in those pyrites? So first, we determine 4 gold events based on their textures and their location in pyrite textures. First, we have the gold 1 and 2 that appear as random inclusion in the pyrite grain. But as you can see in the near-infrared, it appears that the gold 1 is an inclusion in primary textures, whereas the gold 2 inclusion are hosted by the Pyrite 3. And it's also interesting to note that these gold 2 inclusions are mainly concentrated at the border between the Pyrite 3 and 2, represented by the dashed line, and that may be interpreted as a dissolution from. Then we have the gold 3, which is this polymetallic inclusion plan that cross-cut at least the Pyrite 1 to 3. And finally, we have the gold 4 that is precipitating in the open cracks. In terms of abundance, gold 3 and 4 are the most abundant, and the gold 1 is the less abundant. So just to make an overview of the pyrite and gold events timing. So first we have the gold 1 that is related to the primary pyrite textures. Then we have the gold 2 that is related to the pyrite 3. Then we have the gold 3 that is the plane that crosscut at least pyrite 1 to 3. And finally, the gold 4 that is the latest event, gold precipitation event in the system. But what about the freeze inclusion? So since in the history of the study of 3D inclusions in the orogenic gold deposits, those 3D inclusions have been studied in quartz. Here it's a review, or it's a study of Boulier and Robert in 1992 in the Sigma mine, and the different type of 3D inclusions that you can find in this deposit. So you can find some carbonic 3D inclusions, aqueous carbonic 3D inclusions, and aqueous 3D inclusions. In the study of tuba in 2021 from different Abitibi, gold deposits in the Abitibi, they define 3 types of 3D inclusion. First one is the carbonic, second one aqueous carbonic, and the third one is the aqueous. But what about the 3D inclusion in the pyrite from Triangle and Ormaque? So first of all, we have not pure CO2 3D inclusions in the Triangle and Ormaque. So my type 1 is the aqueous carbonic 3D inclusion. It's the most abundant 3D inclusion, it's 96 3D inclusions in both deposits, and they have a variable CO2 content. Then we have aqueous salt 3D inclusions. I've divided them in 2 different types. First one is the H2O and NaCl 3D inclusion. That is, both have only found in the shear veins of Triangle, and they presented vapor phases around 5 to 10%. So first one is type 2 is H2O NaCl, and the third one is H2O CaCl2, and I will talk about it later. So the first one is the aqueous carbonic 3D inclusion, the most abundant. As you can see, they can be primary 3D inclusion in the Pyrite 2 zoning here, for example. They also appear as cluster or isolated. And here you have an example of, you have this 3D inclusion where you can see the vapor, the liquid carbonate, and the aqueous liquid at room temperature. But the primary 3D inclusions are a bit rare compared to the secondary 3D inclusions. Here you have a plane of 3D inclusion that cross-cut the primary textures. In this case, you have a big carbonic phases compared to the aqueous phases. And those one are the most abundant. Then we have the type 2 and 3. Both appear only as 3D inclusion plane that cross-cut at least Pyrite 1 to 3. And that's it. So from the microthermometry data, so here in blue you have the type 1, in red the type 2, and in green the type 3, which is the CaCl2 H2O 3D inclusion. First of all, which is interesting to note is that the aqueous carbonic 3D inclusion always have an homogenization temperature between 250 and 325. The things that we have to keep in mind is that those 3D inclusions have been studied in pyrite, and the things that I didn't say before is that when we increase the temperature, the transmittance of the pyrite decrease. So I can't really observe the homogenization temperature if it's above 320, 350 degrees C, usually. So maybe they have some temperature that could be higher, but I could not observe them. The salinity is ranging between 0 and 15 weight percent equivalent NaCl, but most of them are below 5. Then the type 2 is the H2O NaCl. It's ranging between 150 and 180 degrees C with a salinity around 5 weight percent. And the last one, the H2O CaCl2, have a bigger salinity compared to the others, most important salinity. And those salinity, even if we have never seen daughter faces or halite cubes inside those fluid inclusions, the CaCl2 have been observed because of the eutectic temperature, which was between around -52, and the ice melting temperature. So to compare with the results in the precedent study, so here you have all the data from Tuba 2021, so from the Orogenic gold deposit in Abitibi. As you can see, our type 1 aqueous carbonic fluid inclusions correspond to some of the primary data from the other deposit in the Abitibi and in the quartz. And we have not the same trend as it is here. And the CaCl2 correspond to the late fluid events recorded in the Abitibi gold deposit. Here you have a comparison with the Lac Herbin deposit. So we have the same type 1 and also a bit the same, or almost the same type 3 fluid inclusions. The only difference is that the Hervé Réseau got high temperature aqueous fluid inclusions that we never saw in our deposits, and could be related to something that could a magmatic fluid inclusion or related to magmatic events. And finally, the pink and blue squares correspond to the data from Robert 1995 that they've got in sigma in the quartz the fluid inclusion from the quartz of the sigma mine. We also have the same range for the aqueous carbonic and similar range for the aqueous salty fluid inclusions. And to finish, it's just the first isochord that I've drawn. It's a graph modified from Tuba. So all these isochords are only from aqueous carbonic fluid inclusion, so the type 1. But just the first things, the first things that is interesting to notice is that if we use the temperature that have been defined in the triangle deposit around 320 degrees C, it means that the primary and secondary aqueous fluid inclusions are trapped around 6 to 7 kilometers. So it's something that seems to be coherent with the literature. But also I think that is interesting is that the pressure, the homogenization pressure of the type 1 aqueous carbonic secondary fluid inclusion plan always exceed the range of Solvus model. So maybe that means that those secondary plan of aqueous fluid inclusions appears in an immiscible regime. And just so to finish, so this primary fluid inclusion might be preserve the pristine fluid inclusions that precipitate the gold 1, and secondary type 1 fluid inclusions might be related to the gold 3, and the gold 1 probably formed around 6 to 7 kilometer depth. And also just to tell you that I just finished to compile this data like yesterday, and I will go to do the laser ablation on Friday at Zurich. So if you want to see the last result with the laser ablation, come to the GACMAC or even the Goldschmidt. I will present you the last data and the last interpretation. And thanks for your attention.